Algebra 2, compound interest. The compound interest formula is b of t equals p times 1 plus r divided by n, all raised to the power nt. P is the initial deposit, r is the annual percentage interest rate, we call APR, and that is written as a decimal. N is the number of times the interest is compounded per year, and t is the time in years. Consider that $1 is invested at 100% APR. Now, this is not a plausible situation, so just bear in mind we are deriving a number, and so we're kind of looking at this particular situation to help us notice something. It says the balance is a function of the time in years t. For part A, we will determine the balance in 1 year, so that in our formula is the variable t, if the interest is compounded twice per year, and so that's the value 2 in our formula for the variable n. So using the formula b of t, I've replaced the t with a 1 because this is 1 year, is equal to p. P is also a 1 because we started with $1, times 1 plus r. Well, if the interest rate is 100%, then r is actually 1 because you move your decimal point 2 places to the left to represent your percent as a decimal. The n is 2 because it's compounded twice per year, and then the exponent is 2 times 1. You can type this in at Desmos.com or on your graphing calculator, and you will get exactly 2.25. Part B says, determine the balance in 1 year if interest is compounded monthly. Well, there are 12 months in a year, so the only thing that will change here is the 2 will now be a 12 because there's 12 times that you're compounding in a year. And then up here in the exponent, you now have a 12. Now, this did not come out to be exactly 2.61. This needed to be rounded, but it's $2.61, so it did increase a few cents from 2 times a year to 12 times a year. In part C, determine the balance in 1 year if interest is compounded weekly. Well, there are 52 weeks in 1 year, so the 12 now is changed to a 52 because that's the number of times compounded each year, and the 12 up here is now a 52. So that gave us $2.69. So it did not increase quite as much from monthly to weekly. In 1D, it says determine the balance in 1 year if interest is compounded daily. Well, there are approximately 365 days in 1 year. So in our formula, the only thing that changed again is that n value. It changed to 365 here and here. And this again had to be rounded off. You'll notice it just barely went up, only 2 cents, $2.71. So, as the number of times the interest is compounded per year increases, you'll notice that this balance is approaching a number 2.7182, which you may have never seen before, but this is called the irrational number Euler's number, or Euler's number is the actual pronunciation, and they represent that with an E. Euler's number is used in a formula for a balance of a bank account that is compounded continuously. And that means it's not just compounded once a week or once a month or once even an hour. It's actually being compounded all the time. And in that formula, this E is it represents that number, Euler's number. Now, if you have a graphing calculator, I'll show you where that number is located. And this is the TI calculator, but you can also type this in Desmos, and it does recognize E as Euler's number. You'll type second divide, and it'll pull up the E, and when you press enter, it's going to give you a decimal representation. Now, keep in mind, this number never repeats, and it never terminates. So it does look like it's repeating here, 182, 182, or whatever, but it's not. It keeps going. And another place you can find that same number is second ln, which is down here up below log. and it'll say e to a power. If you'll put a 1 for your exponent, it'll give you the same value. We will be using this number more in future lessons. Number 2, write an equation for the balance in an account with an initial deposit of $4,000 and an APR of 4% if the interest is compounded continuously. And then we're going to answer 2 questions about this. So what I've done is I've actually graphed this in Desmos for you. So the equation for number 2 would be B of t, t being the time in years, equals $4,000, that would be the P in the formula, times E, which is Euler's number, and that is raised to the power 0.04, that's your R, or your interest rate, times T, which is the variable for time. I spent a while working on this window, but you definitely want your Y values to be very large. I would say at least 7,000. I have my X's going over to 70. That's probably not necessary. 30, maybe 25 is plenty. But this is a reasonable window. So question 2A says, what is B of 5? A quick way to find it is just to type B of 5, and it will give you the output. So this is telling us 5 is our years, and our output is our money. So the balance in the account will be $4,885.61. So you would want to round that off. Part B says, what is the value of T when B of T equals $7,002.70? Well, you can just type in Y equals $7,002.70. And what will happen is it'll place a line on the graph for you, and it'll actually show you that point. So if you'll click on it, you'll be able to see that 14 is the value for T, or time, in this situation. And so on your paper, you would say in 14 years, the balance in the account is $7,002.70. So to summarize, we now know the balance in an account can be represented by this formula when interest is compounded continuously. P being the initial deposit or principal times E, which is Euler's number, raised to the RT, where R is the interest rate written as a decimal. So the first thing we wrote was the equation. B of T is equal to $4,000 times Euler's number raised to the 0.04 times T. And then we plugged in a 5, very simple, $4,000 times Euler's number raised to the 0.04 times 5, which gave us this amount. So in 5 years, the balance is $4,885.61. And then finally, we didn't know 14, but we knew the output. So we drew a horizontal line across our graph to find our input, which was 14. And so we now know in 14 years, the balance is $7,002.70.